So we're looking at operations. We're going to add, subtract. Multiplying and dividing is the easiest of the operations, which is odd because usually they're the harder, and adding and subtracting is easier. The adding and subtracting is a little bit pickier because of the way you have to combine like terms. The product of radicals. For any real numbers a and b, if you multiply them together, it's a times b underneath. That's nothing new. We had that same property when we simplified square roots in chapter 5. If n is even and a and b are both non-negative, and if n is odd, then what do you think? So if n is even, a and b must both be non-negative. If n is odd, then it doesn't matter. They could be positive or negative, because we just discussed that odd can have negatives. So let's start easy. What is the square root of 2 times the square root of 8? What is 2 times 8? What? 16. And the square root of 16 is 4.
What? No way. No, it's 4. 96 square root of 27.
Yes, the next one is 3. The cube root of 3 times the cube root of 9 becomes the cube root of 27. That's what I was just going to say. I wanted you to notice that when you multiply a square root times a square root, it does not change the square root to a 4th root. Or a cube root times a cube root does not change that to a 9th root or a 6th root. So that becomes the cube root of 27, which is 3. The reason it doesn't change them is think about the idea of what a square root represents. So that's like 2 to the 1/2 times 8. What did I draw?
That's really weird.
To the 1/2. Or, so the idea is that it's kind of like,
I don't know how you got that out of that.
the square root means the 1/2.
Okay.
So the rule is that you multiply these and keep your exponents the same. And that's kind of like our exponent rules. All right, simplify the square root of 16, a 24, b 13.
We should get 30. Yeah.
Where's 3? Oh, sorry. Okay, so 32 becomes what?
8, 4.
Yeah, did we do these ones yesterday?
2,
Oh, maybe
4.
I
4
swear.
square roots of 2.
We need like 32 x to the 5th.
All right, that's why I have them.
4 square roots of 2.
So you get 4, because it's 16, and 2. X to the 8 is divided by 2, because the square root's the 1/2. 8 divided by 2 is
4.
So you get x to the,
4.
and you're done.
I like smaller classes a lot more.
I do have one question. Why would the 2 be in the thing instead of the 4?
Because the 4 came out as the square root of 16. So the square root of 16 became 4. So 16 times 2 was 32. Okay? Here's a perfect example. Square root of 16 is
4.
a to the 24 becomes
12.
b to the 13 is odd. So you make it 12 and keep 1 behind. 12 divided by 2.
6.
So B6 comes out and B stays in.
That's so weird. Oh,
What is it?
That's that answer.
What did you say?
Alright,
Oh, yeah.
so, what's the rule? You multiply the outsides and you multiply the insides.
Okay.
And when you multiply exponents of variables that are the same, what do you do to the exponents?
Nothing.
wait, on the outside?
On the outside ones, we do nothing. On the
Absolute
inside
value.
ones, we.
Absolute value.
4, 8.
Okay, let's go through. What's 5 times 3? So this is a cube root. So what's, negative 12 times 18.
Here, let me do it.
No, do it in your head.
144, 144,
216.
6.
216.
I was getting there. Okay, negative 216. Now, A times A squared. So if you multiply A times A squared, it becomes what?
830.
Yeah, because you add the exponents. So this is going to become A cubed. So B to the 4th times B to the 6th. The second becomes. I said it. What?
I said I caught you up there.
Well, I already said it instead of, I said B to the 6th instead of B to the 2nd. Yeah. All right. 216 is a perfect cube because it's a cube root now. So what number multiplied together?
6.
It's 6.
Dang, who said that?
And no calculator in my hand.
Who said
So you have 15 times negative 6 because it's a negative and you're allowed to take a negative cube root. The cube root of a negative number is just negative.
Be A, leave one behind.
No, it's the cube root. So you need 3 of them, so it's A. So if it's B to the 6th, you need sets of 3, so it becomes B,
Squared.
yes. And 15 times negative 6 is negative 60, negative 30, negative 80.
Maybe.
80?
Negative 90.
Oh yeah, 60 and 30, 90, thank you. Dude, I was losing my mind for a second. I'll spend all those kids in my study hall.
Okay, this ain't that bad.
No, that's what I said. Today is not bad. So, what's this root? It's a,
4th.
so that means we're looking for 4s.
Okay.
So you're dividing exponents by 4. So 2 times 3 is,
2 times 3 is 6.
6.
and then you get the 4th root. 8 times 2 is
16.
x cubed times x to the 5th.
58.
Y squared times y squared.
1 to the 4.
Okay, so the 6 stays. The 4th root of 16 is
2.
x to the 8. 8 divided by 4 is,
X squared.
and 4 divided by 4 is,
1.
however, this is even.
Absolute.
This is even.
Absolute value.
Absolute value of y.
How did you get 2 for
With the absolute
It's
2 times 2 times 2 times 2. 6 times 2 is 12. X squared, absolute value y.
that absolute value stuff is easy.
Wait, why is? Oh, it came out odd. Never mind.
Yep,
That absolute value is easy to forget.
it is. So the second part of today is dividing. I said multiplying and dividing is easier than adding and subtracting. So today is multiplying and dividing. Monday is going to be
A little bit harder.
adding and subtracting.
What are the people in King of, what's that place called?
0 point, they're just going to watch this. Because it's a field trip, so they don't get extra days.
I'm super happy.
All right, so the nth root of a over b is the same as the nth root of a over the nth root of b. That's the rule for division. You can break it up into 2 or keep it in 1. So the cube root of 27, or the square root of 27 over the square root of 3 is the same as taking 27 divided by 3, which is 9. Square root of 9 is 3. Similarly with a cube root, the cube root of x over 6 divided by 8 could be thought of as the cube root of x to the 6th over the cube root of 8, which is x squared over 2.
Square root of 9 or 2. No, 3.5.
Alright, so yeah, 9 and 4 are both perfect squares, so this becomes, okay, 12 and 4.
X to the 6th over 2. Yeah, it is. What's going on with that first one? It's a little wacky.
This one? So, what's in the denominator that we haven't had happen yet?
Square
root.
So, you can't have a square root in your denominator. Do you remember how we couldn't have i's in our denominator? We can't have square roots in your denominator. That's like a mathematical no-no. So, with the i's, you multiplied by the complex conjugate. With a singular square root, we're just going to multiply by itself. No, it's even easier than that. So you want to get rid of the square root of 5. So how do you get rid of a square root? Well, you need itself. So if you multiply by the square root of 5 over the square root of 5, that's really the same as multiplying by
1.
But we know if we take 2 square roots and multiply them together, no. You get 3 square roots of 5, but 2 square roots times each other, you multiply those numbers together. What is 5 times 5?
5. So it's 5.
So you get 25, but we know that the square root of 25 becomes a perfect square. So if you multiply by itself, you always create a perfect square, which eliminates the square root. So this becomes 3 square roots of 5 over 5. If you were to take your calculator and do 3 divided by the square root of 5, or 3 square roots of 5 divided by 5, they're identical. It's like equivalent fractions. 1/2 is equal to 2/4. In math, you just rationalize that denominator by multiplying by 1, making it equivalent. So here, my suggestion is simplify first. You have 2 square roots. Simplify them. The square root of x to the 6th becomes what?
X to the 3rd.
Okay, but what does that mean?
Absolute value.
Because it's even, odd.
Over
So simplify the square root of y to the 7th.
y to the 3rd square root to the y.
So you get absolute value, no absolute value, sorry. You get y cubed with a y left behind.
Now you have to multiply by the square root of y.
Exactly, square root of y on top and bottom. Well, so that becomes x cubed root y over y 4, because you had 3 here and 1 there. Your homework is that front and back next page. I think front and back. Let me see this real quick. It might just be a front. Oh no, I spaced it out for you. It is front and back, but like there's only like 8 problems. I super spaced them.